Welcome, students! Today, we embark on a thrilling journey into the realm of kinematics. Kinematics is the branch of physics that describes motion, focusing on the concepts of position, velocity, and acceleration. It allows us to understand how objects move and how their motion can be analyzed and predicted. At its core, kinematics deals with the mathematical representation of motion. To describe the motion of an object, we need to consider three key quantities: displacement, velocity, and acceleration. Displacement refers to the change in position of an object. It is a vector quantity, meaning it has both magnitude and direction. For example, if an object moves 5 meters to the east, its displacement is 5 meters east. Displacement is often represented by the symbol dx, where delta denotes change in and x represents the position. Velocity, on the other hand, is a measure of how fast an object is moving and the direction of its motion. It is also a vector quantity and is defined as the rate of change of displacement with respect to time. In simpler terms, velocity tells us how quickly an object is changing its position. It is calculated by dividing the displacement by the time interval over which the displacement occurred. Velocity is represented by the symbol vev. Acceleration is a measure of how quickly an object's velocity changes. It represents the rate of change of velocity with respect to time. If an object is speeding up, slowing down, or changing direction, it experiences acceleration. Like velocity, acceleration is also a vector quantity. It is calculated by dividing the change in velocity by the time interval over which the change occurred. Acceleration is represented by the symbol a. To analyze motion, we often use graphs and equations. Graphs, such as position time graphs or velocity time graphs, provide a visual representation of an object's motion. They allow us to identify patterns, trends, and relationships between different quantities. Equations, such as those derived from the principles of kinematics, provide mathematical descriptions of motion. Equations like the constant velocity equation, v equals sine dx dt, or the constant acceleration equation, v equals sine u plus at, help us calculate unknowns and make predictions about an object's motion. In kinematics, we often encounter specific types of motion, such as uniform motion or motion under constant acceleration. Uniform motion occurs when an object travels at a constant velocity, meaning it covers equal distances in equal time intervals. Motion under constant acceleration, on the other hand, describes situations where an object's velocity changes at a constant rate. Examples include objects in free fall or vehicles accelerating or decelerating. Understanding kinematics is essential for comprehending the fundamental principles of motion. It allows us to analyze real-world scenarios, predict future motion, and solve problems involving moving objects.